In this module, we'll have a look at the different types of data stores that we could create on our ESXi host. We'll also have a look at the different data stores uh, operation that we could perform. And finally, I'll discuss the management of overcommitted data store. As we may recall from our introduction course, a data store is basically a logical container on our ESXi host, and this logical container is used for storing our ISO images, our VMs, and our templates. So basically, the data store, it hides the specific of the underlying storage devices. So the storage capacity for a data store, they could come from a couple different sources, like our iSCSI target, or Fiber Channel SAN, or our NFS server. And the creation of our data store, it just connect to those backend storage medias. All right, so let's take a look at the different types of storage we could create, or different types of data stores. So data stores could be formatted with either the VMFS file system, or it could use a file system that is native to a remote storage device, which in our case would be our NFS server. So our ESXi host basically serves as a NFS client that will be connecting over to that NFS server share. I have a separate slide here where we'll go through these in a bit more detailed manner. So let's start with our VMFS file system. The virtual machine file system, this is a clustered file system that was designed for the storing of virtual machines. So it facilitates multiple hosts concurrently sharing our virtual machine storage. So it is a file system that is proprietary to VMware. So VMFS, it has a feature called a block level distributed lock-in. So what this basically does is it ensures that the same virtual machine is not powered on multiple hosts at the same time. And the storage capacity for VMFS data store, it could come from one LAN or from multiple. VMware recommendation is we match one data store to one LAN. So in the backend, VMFS, it could be deployed on directly attached storage from fiber channel storage, fiber channel over Ethernet, or iSCSI storage. Okay, as we'll see in our demonstration too, once we have a VMFS data store deployed, we can easily increase or dynamically increase the storage capacity of a VMFS data store. I'll demonstrate this actually in our next module, creation of data store, increasing the capacities of data store. We'll demonstrate both the VMFS and NFS data store creation. So that's what I want to discuss next here. We have our network file system. Before I move on to NFS, let's just recall how a virtual machine is seen, or the storage for a virtual machine is seen. So the virtual disks, they are stored on VMFS or NFS data store, and they basically appears as a device mounted on a SCSI controller in the virtual machine. So the physical architecture of the VMFS data store, that is hidden to the guest OS. So the guest OS, all it sees is the native file system, example NTFS, and not the actual VMFS file system, or the NFS file system for that matter. So our ESXi host could connect to a NAS that is running the NFS protocol, the file sharing protocol. ESXi version 6, it supports both the NFS protocol version 3 and version 4.1. Okay. The NFS data stores, they are treated very similarly to VMFS formatted data stores. However, with NFS data stores, the file system is not managed or controlled by the actual ESXi host. The NFS client that resides on our ESXi host, this would connect over to the file system on an NFS server. So the NFS file system is running on a remote NFS server and is basically exported to our ESXi host. In the last two modules, we would have covered setting up of our NFS server, both on OpenFiler and Windows Server. In the next module, I'll demonstrate how we'll go about doing the exporting of those NFS monks onto our ESXi host. It should be noted too, our NFS exports, they would need to be mounted on the ESXi host with the no root squash configured before we add that to our actual ESXi host. So we would have seen this or enabled this whilst we were configuring our NFS server. Also, for those NFS export, if we would be, NFS data store, if we would be running virtual machines off of those data stores, we would need to grant the read-write access to those exports. And we would have done that whilst setting up our NFS. Finally, once we have our NFS data store mounted on one of our ESXi hosts, we can just right-click that data store, NFS data store, and mount our additional host onto that. So let's move on to our next slide here. These are some different operations that we could perform on our data stores. So I'll go through most of these once we get to our demonstration. We would have covered some of these too in our introduction course, like inflating our tin virtual disk. But the remaining in the list here, we'll cover these in our demonstration. Okay, so next we have management of our overcommitted data stores. So if we are using tin provisioning or tin storage in our virtualized environment, we'd want to be careful that we're not overcommitting our data stores. When this happens, we are basically assigning storage for virtual machines that we don't have in our backend storage or on our backend storage, and this leads to all sorts of problems. Okay, so vSphere presents us with a few tools to monitor our overcommitted data stores, and we want to make use of them. Tools like alarms, which we could use to monitor our data store capacity. We'll cover alarms in our monitoring course. But once we have identified an issue with our storage capacities, we would want to increase the capacity of our underlying storage device or create extents for our data stores. Or we would want to use the storage vMotion feature to migrate our virtual machines to a larger capacity data store or migrate it over to a data store cluster once we would have identified a problem with storage capacity.